All right, so I'm gonna review some things, then you're gonna check to see what you got, and then we'll start going from there. Right? I need you to watch your periodic table. All right. So periodic table, right? So we have groups and rows.
Yes.
Right? Columns, and they're also called what? So it's with L. Because groups live in the same home. If you live in the same home, you call.
Well, sorry, I just thought of whatever starts to happen.
People that live in your home, what do you call each other? So it's with F. Family. So we say groups, columns, and family. Okay. So the rows are period. What else? Two words. Starts with an E. Second word starts with an L.
Is the first word element? And there are two rows?
Yep. All right. So your groups are columns and families. Sorry, your columns are groups and families. Your rows are pairs and energy levels. Right. From the column, what can you get from the group name? From the group number? So let's say I have group 1, group 2, group 16, group 17. By telling you that, what else do you know? Well, before I determine charge, I will determine what? Is a certain type of electron found on the outer.
Valence?
Valence. Okay.
Okay.
Yeah. 1, 2, 16 has.
16 has 6.
17 has.
7.
All right. Now, one of the reasons I mentioned that is because on that document probably is going to talk about charge. Right. So we want to look at why we have certain charges. And I like to look at it this way. 1, 2, 3, 4, 5, 6, 7, 8. 8 is my magic number. We say that atoms,
It's an octet.
it's an octet. Atoms gain, lose, and share electron to resemble noble gases. All right. And having 8 valence electron, that's your group 18. That's your noble gas. Right? With one exception. So when we look at this, we say, okay, if I have 1 or 2 valence electrons, I could go that way. That's take me 6. Or I could just get rid of 2. What's easier to do?
Get rid of 2.
Right. So knowing that, you're always constantly saying valence electrons help me figure out charge, right? But it's more to that. So if I gain 6, each electron is negative. Right? If I gain 6, each electron is negative. That's -6. And we all agree that's no good. Right? Gaining 6 is hard. But if I lose 2, each electron is negative. As I lose negativity, I become more positive. Right? As I lose negativity, I become more positive, right? So the last time you were upset and you stopped being upset, were you more positive or more negative? Right. So that upsetness is that negativity. Right. So we're going to talk about this concept again. So if I'm in group 16 having 6 valence, is it easier to gain 2 or get rid of 6? gain 2, right? So all good on that. Going back to this one. So if I have one valence, do I gain 7 or lose 1?
Lose one, right?
Lose 1, right? So if I lose 1 positive charge, I am gonna be what? If I lose 1 negative charge, like it's negative. If I lose 1 negative charge, what do I have left?
You've got them.
Yeah, you don't have.
But, oh,
There's just valence electron.
um,
So I could gain 6 or lose 2. What's easier?
which one are you talking about? Which one else? The second one?
Oh.
Oh, that, it's easier to like lose two
So what's my charge?
positive.
Skipped all the way to group 16. Still want to get to 18. How many away?
One.
1.
Oh, two. Oh,
Two.
from 16. Okay.
Right. So what's my charge? If I gain 2 negatives.
Two positive.
It's opposite, two negative.
Oh, okay.
Because I'm always losing and getting negative, right? So if I gain negative, I become negative. So 17 to 18 is how many?
It's one.
Right.
Uh-huh.
So 1 away. So what's my charge?
There's. Negative. No, sorry.
Yep. No, that's right. -1.
All right.
That's right. -1. So we want to remember that because it pops up often on your periodic table, on the SOL and our exam. It doesn't give you this information.
Mhm.
But questions will talk about this information. So you have to understand it. So let's say I'm in group 15. What should be my charge?
5 rounds.
5 valence. So what should be my charge?
-3.
Good. Good. All right. So 13 is the last one we actually use this pattern with that are positives. So group 13 has 3 valence. Having 3 valence, what's gonna be my charge?
3 rounds. Three.
Positive or negative.
Not positive.
So we want to remember that pattern. Right. So that was charge, right? So what can I do with the charge? I can create ionic compound, right? From the chart, I create ionic compound. So let's say I see this CaCl2. What would I call it?
Ca calcium plus.
Well, let's say I told you magnesium nitride. What is my chemical formula? How do I figure that out? Right. So I need to say magnesium. I need to say nitrogen. I need to say that magnesium is in group 2. Group 2 would have what charge?
2.
Positive 2. Nitrogen in group 15. Group 15 would have what charge?
-3.
-3, right? So now we have that information. Now we do a method called drop across, and I'll show you the math that proves this is right. So how many magnesium will we have?
Oh, wait, +2 -3, right?
Nope. What's that number?
-3.
What's that number?
+2.
So why do we say positive and negative when it's a subscript? Because the count quantity 1, 2, 3, 4, 5, like that. Right. So what does the math show for this? Right. I know that each magnesium is positive 2. There's 3 of them. Positive 6. Each nitrogen is -3. There's 2 of them -6. Together, that equals 0. So the math proved that we can do this drop and cross method. Right. Math proves it. We're good. Now, within looking at these ionic compounds, we also need to look at transition metals. Right? Here's like copper. Lead. But we also need to know that there's some special transition metals that their charge is always that number. Okay. Zinc, cadmium, and silver. And there's a couple of the yttrium, for example. So when I see copper chloride, it doesn't give me enough information, right? Because let's say I was naming this FeO and Fe2O3. If I name them by the elements, this is called iron what?
Oxide.
And this is called
Iron oxide as well.
so I just name it by the elements, exactly the same name.
Right.
One is more dangerous than the other, right? To your body.
Mhm.
So I need to know if I'm creating a compound, a medicine, which one I should use.
So I think the difference would be like writing the Roman numeral.
Yeah.
Yeah.
So the method we use to write the Roman numeral that is based on the charge.
It's like the charge of the transition now, we should always look at.
So for the charges of the transition metals, we use Roman numerals because most of them have more than one options. Okay. So when it's oxygen, it's often easy to work with, right? Because oxygen is often negative what?
Two.
-2. And we saw here that a compound must have a zero charge.
Mhm.
So for this to be zero, oxygen has to be what? Not sorry, iron has to be what?
+2.
+2. So we write a 2 right there.
That one's strictly.
So we're careful with that. And we can do the same thing here. Oxygen is -2. How many of them are there? -6, right?
Mhm.
So total here has to be what?
Positive.
But there's 2 of them. So each is,
It's gonna be 12.
nope, 6 divided by 2.
6 divided by 2. 3.
So we call this iron 3 oxide.
Or you could, you could also like flip the charge. Sorry,
Yes,
yeah,
we
not
can.
the charge, the subscript.
Yeah.
And that could get you the one.
So the reason we can do that is because of this method here, right? And what you just mentioned is this Fe2O3. And this works when both of them have a subscript more easily than other times, all right? Especially with the transition metal. So if we were creating this compound, this one started at +3. This one started at -2. All right. So the math proves we can do that, but we have to be careful with lead and tin. All right. So SnO2.
Yeah.
PB. Oh, no. If I just reverse its method, I get oxygen having what charge? If I reverse this, what number? That's a 1. So what would oxygen's charge be?
-1.
Right? And it's not, all right?
Mhm.
It's not. So we need a different method. The method we're going to use is the method we use here. All right. So I'm going to write that again. SnO2. Each oxygen is -2. There's 2 of them. That's -4. So Sn has to be what?
Positive 4.
+4. So going back over here, each oxygen is -2, so
Mhm.
PV has to be
Positive two.
+2, right? So for that one, we'd call it tin for oxide. For this one, we call it lead 2 oxide. And I say lead and tin because they're in the same group. And they both have this ability to be either 2 or 4. Okay. So when with oxygen, we really have to be careful. So I'm going to take 5 minutes. And then you see what else, if that helped you with anything else.
Mhm.
Okay. Charge with an electron,
Negative.
charge with a proton,
Positive.
charge with a neutron,
That's just equal.
charge with a nucleus.
Sure. Positive.
Okay. All right. So let's see what we got here. Yes.
We have one more question. Is this like a review of like all like the units that we've done so far?
Mhm. In a neutral atom, one that has no charge, which 2 subatomic particles must be equal in number?
Proton and neutron. That's what I put.
Yeah, sure. Same.
Neutral. Neutral means equals 0.
Yeah,
So neutrons, you said equal what charge?
it's just neutron. It's just, yeah.
Yeah.
Electrons equals
Um. Sometimes like negative. What? Yeah.
protons equals. So which 2 things together?
Uh, electrons. and protons.
Yes.
Uh,
Okay. And that's your proof. All right. Atom with 12 protons, 12 neutrons, 12 electrons. Who am I and why?
magnesium.
Why?
Because if it's the number of protons equals the atomic number, so it should be magnesium.
Good.
100%.
So all we need to identify the element is the proton.
Yeah.
If we're only given electrons, we need more information. We need to know if it's neutral or we need to know its charge to figure that out. So, every atom has a very dense nucleus. What subatomic particles are found in a nucleus?
Not sure, but I picked protons and electrons.
I think there's something different.
What did you pick?
I think neutrons and protons. And I
Center is the nucleus. Who's on the outside?
would you want me to explain?
Nope. I have a question. Center is the nucleus. Who's on the outside? Who's outside the nucleus?
All those shells,
What's in the shell?
the electrons.
So the electrons are outside the nucleus. Then who was in the nucleus?
Neutrons.
Neither of you said that. Just now you made it sound like you said it. But you didn't say that.
I did say I said protons and neutrons for number 4. I definitely said that. They're like they're inside the nucleus. That's
Okay.
what I thought.
So if I was able to rewind this, I didn't hear it. All right. So you gotta be careful. Sometimes it helps to draw yourself a diagram. If you can't remember it, draw yourself a diagram. How many atoms of sulfur are in this compound? I have Al, S, and O.
Two.
All right. So oh. And that's because I distribute the 3 inside. So it's 2, 1 times 3, and 4 times 3. That's 12, that's 3, and that's 2. So what is my total number of atoms?
17.
Okay. So. Number 6, how many atoms of oxygen are in cobalt?
4.
Cobalt? Atoms of oxygen, I put 9. Because we multiply the subscript.
Oh, yeah, no, I did the wrong thing. Yeah, cobalt was the wrong.
You did the O,
Yeah.
cobalt.
Mhm.
We know.
Yeah.
It's an odd but common mistake. That's why this question is used.
Yeah.
All right. So, which compound has 2 types of elements?
I think D.
I think the B, the second one.
So this is one of those questions that's helpful to just write out.
Yeah.
What you got? So I have Ni, I have O, and I have H. I have C and I have H. You might have C and H again. I have C, I, and H. And this one I have CO, C, and O. All right. So this is 3, that's 3, that's 3. This is 4, but it's actually 2. All right. Because they give you CH, then CH, you have to realize it's one. It's 2 atoms of carbon and 6 H's give you your 2 atoms. So this is why we used to talk about explain your answer. Because if you can explain it, you can get another one right.
Wait, how's the last one? 3, like element?
Because it's CO for cobalt, C for carbon, and O. And each capital
Oh.
letter
Oh.
gives you a different element.
That one.
Yeah, so, capital and then lowercase is one element.
Correct.
Capital.
And that's what messed you up before.
Now-
Yep. Which chemical form has a ratio of 1 carbon atom to 3 hydrogen atoms and 1 nitrogen? So if I was writing this, I would write carbon, I'd write hydrogen, now I would write oxygen, and I want 1, 3, 1, right? That's what I want. So, whoop, wrong element.
Nitrogen.
Nitrogen is 1, right? So in this one, I have 1, 3, and 2 is 5. That one's wrong already. This one, I have 2, 4, so I might be okay, but 1. So that was no good. Next one, I have 1 carbon, 3 hydrogens. So that looks good, but we always recommend you double check everything. All right. So I'm going to check that one. All right. So I have 1 carbon, 2, 4, 8. And that's 4, 6. 6 of those, so that ratio is already off.
Yeah,
All right.
yeah, that's what I see. Okay.
So yeah, it's C.
So 9 starts to talk about energy. All right. So give me a second. Let me look through if we have any other questions related. Here goes a couple related ones. Okay. So these 2 are related to the periodic table. So we're going to talk about these 2 now, right? So I know that mass equals protons plus neutrons. So neutrons equals what?
Mass minus proton.
So in this example, both of these methods, writing the number above the element symbol on the left-hand side and writing a dash and a number tells you mass. Right? Writing a number top left of the element symbol or a dash and a number tells you the mass. So, how many neutrons? To figure that out, I need to figure out protons. So chlorine has how many protons? Excuse me.
Fluorine has 17 proton.
17 positive, right?
Mhm.
So total mass is 37 minus 17 equals how much?
37 minus 17.
20 neutrons. Did you get it right?
No, no.
No,
17.
no.
Okay.
I don't.
So what about, let's look at number 14. Atoms of the same element have different number of neutrons. It's called what?
I split by 6.
Isotope square.
Actually,
So isomers, when you get to college organic chemistry, you'll talk about that one. Radicals and free radicals, we kind of mention every now and then.
Is that like more of a math thing now?
yeah.
Well, plus we have free radicals. That's what I said we kind of mentioned it. Free radicals are elements like oxygen that is by itself not bonded. And if they touch something, they react with it. So we call those free radicals. So your diatomic molecules slash elements, if they are broken and they're just around in the body, they will cause a reaction of some type. Ions we know is a non-neutral atom or species, right? So it's either be positive or negative. So that one is the answer. Then we need to review some more stuff. Not to say that you don't remember it, but I want to review it just in case.
We also doing moles and stoichiometry.
Yes. So let's see. We did ionic compound. What are these called?
These are polyatomic ions, but they have names. They have names.
You know what I mean? NaOH, you'd call it what? You said it before in your lifetime. It's a base. Na is sodium, so sodium. See? That was hydroxide. When you're baking, sometimes you use sodium by that's a carbon, that's oxygen. Sodium by what? I have no idea when you would use that normally. That's sulfate,
Okay.
sulfuric acid. And this, if that's carbonate, that's sulfate, this is. Look at the pattern. Carbon, A, salt, A,
Nitrate?
nitrate. Next one is
Phosphate?
I remember the last one.
Yeah, you go for the last, not
Yep.
the last.
Ammonia.
one.
you'll notice that,
There's a pattern. I know.
but I didn't write in the pattern method, that's the problem. You'll notice that the eights
All have oxygen.
all have oxygen, right?
Yeah.
And what's the atomic number? Whose element has eight?
Oxygen.
Oxygen. So your eights refer to oxygen. So just remember that.
That's a good way to remember.
I'm gonna give credit to Ms. Merritt for that one. She's the last one that did this method, I remember. All right, so that was the end of looking at our bonding when it comes down to compounds, except I want to name something, right? So if I see this, what would I call it?
That's gonna be sulfate.
Okay, so what's that called then?
And oh my god, I can't remember.
Group one.
You can look at it.
Oh yeah, sodium.
Last part?
Sulfate.
Uh, this one's called
Aluminum phosphate.
that one's called atomic
Ammonia.
ammonium.
And then, well, instead of chlorine, we put chloride.
Good. What about this one? Yep. No. Yeah, yeah. All right. What about this?
Isn't
Yeah.
yeah, iron, yeah, iron phosphate.
Close. Real close. I would almost give it points, but not. Not yet.
Means it's a transition of. And
It's a transition.
Mm-hmm.
That's easy. We're not stopping so it's not a thing. I'm calling you to help, man. I need your help.
What? I gave you a hint. Give you a hint. Go ahead. Iron what?
So first, we have to switch, like, we gotta look at the charge of the iron. But, mainly we just switch the subscript.
Okay.
Yeah, the outside subscript.
So when I switched and I put that back to where it was, what was iron before?
Iron was positive 2 before.
Well, what goes there?
The 2 in Roman numeral.
Whether you put the parentheses or not, it's okay. So since we're on naming, let's talk about binary covalent. I guess I don't know that many binary covalents. Wow. Di, nitrogen, tetroxide. All right. I see nitrogen and I see oxide. All I need to figure out is how many of each I have, right?
Yeah.
You know what? This is the next unit we're gonna get to. All
Okay.
right. So let me just say 1, 2, 3, 4, 5, 6, 7, 8. Mono, di, tri,
Quad again? Is it quad?
tetra. Five-sided building is called.
I'm only thinking of like,
Math term.
It is math. Five-sided shape.
I don't know, I'm just thinking quantum, I don't know.
Poly? Ooh,
Another letter. Huh.
Penta.
6 sides,
Hexa.
7,
How do I say so?
8, you know.
I don't know. Okay. I have a question. Is this unit 6 or unit 7 you're talking about?
This is the next unit.
Unit 7?
This is unit,
We started with unit 6.
we just started 6?
Yeah, we
Then it's
just,
unit 6.
alright.
And this is Nana. And 10, you know. You know. You know 10.
Dia, D-I-A, is that it?
Close. It is D.
I know these terms, but I'm like taking.
So
them.
think of metric, the metric system, 10. The mass shape with 10 sides is a D something gone.
Diagonal?
Close. There's a letter in the middle. Gone. Pick a letter.
I want to say M, but
Nope.
it's not right. Yeah.
That one, nope.
D?
Dedagon.
Did it?
I
No.
don't know, I'm just guessing.
It's close to the D though. Deca.
Oh,
Deca.
So 10 is Deca. So we'll start this. So when I say die, how many do I have?
2.
When I say penta, how many do I have?
10.
Sorry, tetra.
4.
You remember when we worked with ionic compounds, if you see 2 and 4, you reduce it.
Yeah.
You don't do that for
Yeah, it's called
covalent.
reducing.
You do not do that for covalent
Okay.
because this tells you the name and that's the name. Because this is something different.
Okay.
Right? Sometimes the empirical version actually exists, sometimes it doesn't. But unless you're asked for empirical, you do not reduce it. Empirical means Lowes ratio.
I have another question,
Go.
kind of off topic. But does this come from like Greek or Latin? Like,
It was, I don't know.
I think it's-
Wherever the prefixes come from, where the math, the history of math, we took the math and made it applicable to chemistry.
it seems like very Greek or like the Latin type, you know?
Latin, yeah.
More Latin, probably. Because a lot of science terms come from the Latin.
Yeah, it does.
Because it's also universal.
Wait,
Yeah.
is this like on our unit 6?
It will be. I don't remember if we write it in or we have to, or is it there for you?
I want to take a picture of it.
All right, I'll do that too. Get a little bit of shoot while we can. There.
And this is called binary covalent. And why is it called binary? How many types of You see two types of elements. So. All right, so let's talk about the mole. One mole equals what?
Uh,
Do you have it?
no, I don't remember. It's like six something.
Yep, 6 point.
It's a number that, well, it's basically nothing.
Uh, 0.024.
Times 10 to the
20 something.
close.
Very close, yeah.
23, okay.
Atoms,
Particles.
molecules,
Or particles.
particles, small particles. Formula units. Right? Formula units we use when it comes to ionic compounds.
Okay.
1 mole also equals one mole equals what? There's 3 moles.
I'm only doing a molar mass.
That's the right one. Which is equal to what?
Molar mass.
Where'd you find it?
I think you do like.
It says something and that it has volume. Like
Nope, that's this one. That's that one. Molar mass. Where you find it? You're looking at it right now. So what's that paper called?
Oh, it's a, like the grant, like the mass, right?
You talking about?
That's the periodic
Mass.
from the periodic table.
Mass from period. Wait, so atomic mass, right?
Yep. In what units?
Gram?
Correct. All right. So let's do some problems.
You're gonna short my head.
All right. Let's say I have 37 moles of lithium. I want to convert that to grams. Lithium.
That is a.
Wait, what was molar mass? Mass is the what?
Oh, I have 37 moles of lithium.
Can you go?
Oh,
Yeah, I'm talking about the last one. So it was like mass. Okay, okay. I also want to take another picture of that.
so how do I start this off?
The information you're giving, that's what you should start off with.
So there is another method to this, right? One method is to look everything up that you can think of, then set it up. So
Yeah.
using that method,
Yeah, starting with units.
1 mole lithium equals what number from the periodic table?
Are you asking for its mass?
That's the only thing 1 mole would equal.
All right, it says 6.941.
Gram. Lithium, right? So this says, okay, I pre-think of what I might need. It asks for grams, I look for grams in the periodic table, I write it down. So I know I'm going to use that information.
Yeah.
So you can figure out how to use it. So one method is we use our crossbars, our railroad tracks, our fence method.
He's more like a fence method.
Whatever we put up here, minus the number, goes down here. So we are using the words to cancel out the words. And we know by our initial facts that mole equals mass. So moles equals mass, which is grams lithium.
They must have a relationship.
And it must have relationship before you can use it. So now there's this relationship we found from the periodic table. So that relationship says that 1 mole equals that mass, 6.941. So now I have to get my answer. It's great that I'm able to set it up, but the exam requires you to find an answer. 37 moles. What do I do?
From
What
the
operation?
top, you multiply,
Mhm.
the bottom you divide.
From the top I multiply, the bottom I divide.
You don't have to divide in this one, it's just one. So-
But there's the right method. You practice it.
Oh,
Multiply across, divide the bottom. So no matter what numbers are there, you're doing the same method each time.
Yeah.
All right, give me an answer.
I got 256.817. Yeah, I got 256.817.
Yes.
All right.
But you don't have to round it.
Most of the exam is gonna be multiple choice. So well, you guys aren't taking the SOL, but you find your answer, you write it down, you focus on rounding later. You don't try to do it all together, you're gonna mess up. Get the answer in your calculator, write it down, look at the numbers you're starting with. For the numbers you're starting with, then you can figure out where to round. So, wanna do a more difficult one?
Sure, absolutely.
All right. So I have 375 grams of magnesium chloride. Find the mole. I'm gonna go back to that way we talked about 1 mole equals the mass of MgCl2, right?
Yeah.
So I now know I need to find a mass of what? One Mg,
And
2Cl. What's the mass of magnesium from the periodic table?
It's
24.35.
right. Coin is 35.45.
I need a total. Now I'm gonna go back and start my problem.
$59.75.
59.75 grams per mole. Right? So back to here. Whatever on the
Wait,
bottom.
what? Wait, but isn't it 2 times 35.453? I think something is wrong.
What'd you get?
Well, I'm
It's
gonna,
71 plus or 70.45 plus 24.305.
okay. I got 95.211.
95.211.
Yeah. You wanna see the
Nope,
calculator?
because that gives you 70.903, 24.305. We're good.
906, right? It's 906. Because if you look at the last digit, 3
Yep.
plus 3 6. Yeah.
Correct.
I didn't multiply by 2. That's all. I don't-
What goes on the bottom?
The grams magnesium chloride.
And grams converts to
Mole
mole of the same thing.
and GCl. The unit sign for it.
Now, From our fact, we know that 1 mole equals the mass 95.21. What operation did we do to find the answer?
Multiplication top, division bottom.
Correct. You guys keep working on that document. So we're gonna multiply straight across 375 times 1 divided by 95.21.
But yeah, that was brutal, man. It's more annoying than like serious kind of.
Yeah.
So significant figures, we'll talk about first. We'll do balancing, solubility, then we'll do moles. We may or may not get to moles today. Significant difference, right?
Yeah. I remember some things. I remember that sandwich zeros are significant. That's one of the things I remember.
So significantly is important. So what numbers are important? Numbers from 1 to 9 are always important. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Always count.
Zeros, it depends on where they are.
Right.
Alright, so wait, zeros after, for the very bottom one,
Mhm.
zeros after the one are not gonna be significant, but the ones before it are.
Other way around.
Other way around, okay, so everything past the one is significant. Or
Correct.
everything, okay,
So right. 1, 2, and 3. Yes. 1 and 2. Yes. But what about 1, 0, 0, 1?
I'd say they're all significant because they're
Zeros between significant numbers.
Yeah.
We also call those
Same.
sandwich zeros. This one, eating zeros. Not significant. They come before the number. Zeros that follow a decimal and a significant number are significant, right? So in this case, we have that one and so this is helpful to refresh our memory when we have to do multiplication, addition, subtraction, addition. Now, on the exams, it is not a big deal. When you get to AP chemistry, it is a big deal. But for regular chem, certain questions will ask you that. You should be familiar with it, but it's not a, if you don't know the number of significant digits, you will get the question wrong.
Can we go back to the last one? I want to take a picture. All right, thank you.
So addition, subtraction, we say line of decimals. Line of decimal. Or someone might say button of the decimals. So 123.12 plus 123.1 plus 1.2315. Alright. Make it easier on myself. Rewrite it 123.12, 123.1, and 1.2315.
Oh,
This is subtraction rule. Line up the decimals. Addition subtraction rules are different from multiplication and division. So I need to figure out, where do I stop?
what is it there?
Addition subtraction says I look for the number that has the least number of digits after the decimal. And that's where I stop. So yes, that's a 5, that's a 1, that's a 5, that's a 4, there's a decimal, that's a 7, that's a 4, and that's a 2. All right. So I look at this number here and I say, what does it do to that number? What does it do? Does it leave it at a 4 or does it push it up?
Oh.
So my final answer is 247.5. Right? It doesn't say what addition subtraction. It depends on the number of digits after the decimal. Multiplication division. It's number of significant digits. Right? 2, 3, 1 times 1075 times 101. Right? How many digits?
3.
How many here?
Also
How
four.
many here?
Yeah, also four.
Oh, significant.
Three. 3. That was 50.
So do I end with 3 or 4? When I end this answer, I end with 3, right? So I'm plugging in the calculator. I don't know. Plug in the calculator.
Do we not put the 1010? We put it 101.
You have to put the numbers in. Rounding comes after you get the numbers. Yes.
So I got a long number.
Yeah.
250.
Oh,
250. Yeah. 250. Yeah. 808. And then 250 again.
no decimals?
No,
It's not division, so we'll have decimal. So what's the easiest way to do this?
just look at the lowest significant digit. So it could round that 8 to a 1 over there on 252. We only look at 2508.
All right, so let's figure out why. So we have 3, 4, 3, so we need the first 3.
Yeah.
1, 2, 3. So I look at the number after it and I say, what does it do to that?
It rounded.
So that becomes
1.
2, 5, 1.
Right.
So here goes the problem. What do I do with all of that? What do I do with those other numbers?
That's actually a very good question. That's a very good question.
Good.
I don't.
I can give you this number of pennies or this number of pennies. Which would you rather?
On the top one.
Yeah.
So I need to make this number similar to that number. So what can I do to it?
Can we just put zeros?
We put zeros.
Wow.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.
Oh.
Or convert to something. What can I convert it to? Good answer, scientific notation. Good answer. That's really good answer. So that's where I want a decimal to be. That's where it is. 1, 2, 3, 4, 5, 6, 7, 8. All right. So 2.51 times 10 to the 8. Positive or negative?
It's positive.
Reason?
There's no decimal.
Okay, and value greater than 1.
Yeah, that's great.
So that's how you do division. You want to do a division one?
Yeah. I wanna see this as reference for picture.
3.27 divided by 4127. Yep, that'll give me the number I need. Yeah.
Or we can go back to the last one, the additions, like whatever table they subtraction. Alright,
Give me an answer.
alright. 3, 5. Alright, yeah, I got a really long number. It's 7.87. 4969 712 times 10 to the 4th power.
Oh, that's a,
Times 10
Do you mean 10 to negative 4?
10 to the negative 4th power.
Because that's not what you said.
Yeah, I didn't say that. Sorry, 10 times times 10 to the negative 4th power.
Okay. So that makes it easier for it, right? How many digits here?
3 significant digits,
How many here?
4 significant.
Which one did we use? 3 or 4?
The lower one.
So start here, 1, 2, 3.
Um,
Does that do anything to that number?
it just dropped. Well, it just drops down. So
So no.
yeah, no.
So 7.87 times 10 to the negative 4 is our answer.
Or how would we write this in like numbers?
No, I wouldn't write it.
How does it
Just,
look like?
this is it.
But how would it look like without like
0.000787.
like that? Interesting. Interesting. Yeah, I don't know that much about this. This one was confusing from the first time around this.
yeah.
Did Miss Woods teach you this a lot? Not really, right?
What?
We don't go over it as much as we used to. Because the questions are often specific to rounding, or just give me the answer.
Yeah.
So if I'm doing a mole calculation, most times the rounding is not what we're testing.
Yeah.
On our free response questions, we tell you to make sure it's rounded significant digits because we're also going to test that as a point. But our multiple choice section, we're not going to give you 7.87 times 10 to the negative 4 and 7.87 times 10 to the 4. Actually, yes, we do. Yes, we do. Okay, so if I'm testing this, can you tell me that these two, if this is the answer, I might give you 7.87 times 10 to the 4.
Yeah.
That's if I gave you this number here. And I say, convert it to scientific notation. I might give you this one. And this one as choices. But if I'm doing a calculation and you have to just write in correct scientific notation, often we don't give it that close together.
Okay.
So that was, let's see, what's the next thing? I'll do solubility charts first. Oh, no. Okay. Mhm. 30, 50, 70, 90, 110. And this is degrees Celsius. So it turns gas temperature. This is grams volume in 100 grams water. Huh? Says know what the graphs are. So multiple things you can be asked. One question is, does the solubility increase or decrease as you increase temperature? And what's your answer? Does the solubility increase or decrease as you increase temperature? What's your answer? Why you say increase?
Uh,
Answer the question is why? Because
because like the temperature increases.
and then the amount dissolves also increases.
Yeah.
Another question you might be asked is point A, point B, and point C. Which one is unsaturated?
B, C, B.
B because it's what?
It's
Hold on.
It's line.
Under the curve. Which one is saturated? Because they're roughly on the curve, and therefore A is supersaturated. All right. So those are all questions you might be asked that does not involve a calculation. So, all right. So let's say I ask you, what is the solubility of this substance at 90 degrees? All right. So I look at 90, go up to the graph, read over to the left, all right? So let's put some numbers in here. So let's say that was
But
20, that was 40, that was 50.
20, 40, 60.
Yeah, 60. Thank you. 80, 100. All right. So at 90 degrees, how much do you have? 90 what?
100 grams diesel.
Is it?
100 gram, okay.
At 90 degrees, I guess the curve kind of curved. Let's try that again. That's a big difference. That's a big difference.
All right.
All right, so
110, so.
I guess I could round it to like 107.
all right, so let's say
107.
at 90 degrees, 107 grams dissolved. So whenever we read from the graph, we're always saying saturated. All right. So another question you might be asked is, what if I am given 112 grams at 90 and it dissolved? What do you know? At 90, I have 112 grams dissolved. What do you know?
So you know at 90 degrees, 112 grams is dissolved. That's one thing. Well, yeah,
That's a given.
that's a given.
So what do you know?
Um,
Is it above, on, or below the saturation value?
above, I think, so it'd be super saturated.
Correct. Right. Let's see. What other question we might ask?
We also have like those cross multiplication things. Well, I forgot what were those.
All right. So another question you might be asked is, I have 112 grams dissolved. This substance is allowed to cool to 85 degrees. Now let's make it a nice number. Let's make it cool to cool to 70 degrees. So I'm there, I'm cooling to 70 degrees. How much falls out of solution? Okay. So I go to 70 degrees. Go up straight. I'll do that straight this time. Read over. At 70 degrees, how many grams would I have?
60,
A little more.
like, probably like 63.
Six.
60.
No. All right. So it's really close to the 60. So you'd say something like 62 grams, right? So how do you figure out how much falls out? That's how much I had. That's what could fit now. How much falls out?
So we do, we do 112, which is what we had, minus how much, 62?
And that's it. And that's how much falls out of solution.
50
Yeah.
grams.
I don't really get that. Where does the 70 degrees Celsius come from?
I ran a different question. I was going by different things you might be at.
That's just like the
But
question.
why do we like subtract from like?
Because I had this dissolved, 112 dissolved, but only 62 can stay. At 70 degrees, only 62 can stay. No more.
Oh, yeah.
So subtracting that tell you how much falls out of solution.
Oh, yeah, so it's like the amount of thing that like gets taken out of it.
Mhm. Yeah. So the other one that you mentioned is, what if I'm not given, what if the question doesn't say 100 grams of water? What if the question says 200 grams water at 70 degrees Celsius, right? So at 100 grams, at 70, the graph said how much?
62 grams.
The graph said 62. But if I have 200 grams, what do I have now?
Oh, 124. Oh, what do you multiply again?
Well, why would I do that?
Because you increased the like the base by 2 from 100 to 200, so you should increase the result by 2.
All right. So the math, pretty much 162 equals 200 x.
Yeah,
And
it's like,
people flip it.
yeah.
Yeah.
It's like on both sides.
Yeah. And I often work it out like you just said. If I did 2 on that side, I did 2 on that side. So whatever method you use works out the same. Any other questions for solubility questions?
Are you able to go back to the last slide?
Mhm.
Ah, It's just the 112 and the 62 grams. It's just I'm kind of getting very confused with that.
Why?
Um,
Normally, it's probably not as much, but those are the numbers we had.
Yeah.
I said that you started with 112 grams, dissolved at 90 degrees. The solution cooled down to 70 degrees.
oh,
So how you thought it got there? It cooled down to 70 degrees. How much falls out of solution, or how much crystallizes?
okay, and then we just subtract.
Now you just subtract.
So let's see. That makes much.
Okay. All right, now for balancing. So play it on the seesaw.
Yeah.
Right. So what we try to do is we know something is off balance, but we always say we have as much as we need in that container, right? So if I have as much as I need in that container, what's the ratio that works out that conservation of mass and matter applies? Right?
Where everything works out, like
Mhm.
1 to 1.
Not necessarily 1 to 1, but whatever I put on the left, I put on the right.
It must be a left must equal right. Reactant must equal product.
So, and that's the basis of balance. Conservation mass and matter, whatever I start with must equal whatever I end with. Can I add more particles? Or I'll get rid of atoms. So H2 plus O2 creates H2O. All right. So I'm going to use H2, right? O2, H2O, right? Because if I change something, I'm changing the whole thing because those are together.
Yeah.
We also know we try not to touch oxygen first. We try. But in this case, there's no anything to touch.
Yeah.
Because we have 2 there and 2 there, so we have to touch oxygen. But if I want another oxygen, I need the whole thing. I need the entire H2O.
Yeah.
And by doing that, I now need how many hydrogens on the left-hand side?
Two.
I now need another H2. So I have 2 hydrogen, 1 oxygen, 2 oxygen. There's another way of balancing. Miss Merritt calls it the bubble method. You'll also see it called the particle method. I had a couple students who love balancing this way, and they're graduating. So don't think of it as the baby method. Think of it as you're able to determine that at the particle level, this is what I see, and that's a good visualization technique. All right, let's do a hard one. making it something it should be. But. FeCO3 and NaOH. FeOH3 and NaCO. All right. Change something.
I'd add. So we can change either side, right? As long as we just pronounce it. Okay,
You should follow a pattern. Have in your head a pattern you're gonna follow. Start on the left, go one atom at a time, leave oxygen for the end, unless that's the only thing you can do.
I would start, okay, so I have CL3 at the left, so I have to increase CL on the right side of the equation to 3.
How would I do that? What do I add?
Just plus 3.
How? What do I add? Of these particles here, what do I add to increase the amount of chlorine? Right? So I want more chlorine. Do I increase this or do I increase this?
That.
So I add another NaCl. Do I have enough?
Nope, you need to add one more.
What? But now, because you added NaCl, you now have more what?
And I'm just pretty sure.
So what I do over here?
Add 2 more.
What is it called?
Like the whole thing or just
The whole thing.
uh
Because you're adding the compound, not just the element.
sodium oxide?
Close. Sodium hydroxide.
Oh,
I have 2. What else do I need? Is that it?
E is both 1 No, because on the right side, OH is being multiplied 3 times, so we need to add OH on the left side of the equation once more.
How many FeCls?
FeCl3 on the left side.
How many?
Yeah, just Fe or FeCl.
The whole thing. How many? The
One.
whole thing. How many NaOH?
3,
How many FeOH3s?
1,
How many NaCl?
3. This is actually like a way better alternative to anything I've ever become. I like it.
The bubble is confusing.
Not to everybody.
I'm not.
That's why we teach different methods. That's why we teach different methods.
So how like why did you like put 3 on the left side and 3 on the other side when I'm talking about NaCl and NaCl?
So at first, you notice 3 chlorines,
Yes.
but on this side, there's how many?
There was only 1.
There's only 1 on the right.
Yeah.
So I just can't add chlorine. I have to add whatever
No.
compound it's in. So it's in NaCl, so I have to add enough NaCls that I have 3 chlorine. Right?
Okay.
So now I have 3 chlorines. Well, because I now added NaCls, I now have Na.
3 NaCl.
But you notice I only put 1 over here, right? Because I was waiting for you to tell me I need another more. But no one said that. What you did tell me is that you need more OH.
Mm.
So we balanced it by OH, which ended up making the NAs equal.
And yeah,
So it doesn't, what matters in balancing is not to start at the worst spot,
yeah.
right? If you don't start at the worst spot, it won't be that bad.
Alright.
And you just keep looking and checking until you're done.
Yeah, no, it's like the concept is easy, but some methods are harder than others. This one really quick.
All right, so let me show you a combustion reaction, all right? C2H4 plus O2 yields CO2 plus H2O.
Yeah, Miss Hall, doesn't combustion mean like either to like catch fire and explode?
Usually, yep. So it's usually carbon and hydrogen combined with oxygen, creating CO2 and water. Right? Which method you want to use?
Bubble method.
All right.
Um,
C4. Ooh, wrong compound. C2H4. O2. CO2. H2O. All right.
Gotcha.
Now what's change?
Okay, we can
Never touch oxygen unless you have to. So start on the left. Fix the left, then move inward.
too much carbon, but
And what's change?
I know I shouldn't do this, but I feel like I have to do something on the right. I was thinking
Mhm.
of adding hydrogen, oxygen, two hydrogen, one oxygen on the right. I know I shouldn't touch oxygen, but I feel like I have to.
Well, you didn't touch it directly. You touched it because you changed the hydrogen. That's
Yeah.
different. That's different. All right. So now I have 4 hydrogens on the left, 4 on the right. What else do I need to fix?
Okay, so oxygen is no. So now carbon, we need more.
What I need?
Add carbon C carbon oxygen. So,
Okay.
or
Very just now, so now on the left.
yeah, we could do that. Now oxygen is wait, hold up. So we had 4, 5, 6. Like 4, like 5. Oh, we can have one more then.
How many C2H4s?
1,
How many oxygens?
3,
How many CO2s?
2,
How many waters?
and 2. No, wait, is that not the C2? Is that it or is that?
Yes. Okay. All right, so I'm gonna give you a tough one.
Well, we should probably use that normal method that we did for last one at least.
All right, so I'll give it. I'll do C. C3H8 plus O2, CO2 plus H2O. I'll use the carbon, hydrogen, oxygen.
Oh, that's my.
Right. So I have 3, 8, and 2. I have 1, 2, and 2 plus 1. Why'd I put it like that? Because they are in 2 separate compounds. So I treat them separately. I have 3 carbons. I need to multiply 1 by. By doing that, I put a 3 up here. Where it needs to go. By doing that, 3 carbons, and I have how many oxygens?
Two. Wait, no.
2 twos. Yep. Well, 3 threes. 3 2.
Actually, three to multiply. Okay, it's good.
Right, so that's 6, right? Go to the next thing. Hydrogen, there's 8 here. I need to multiply 2 by what?
4.
I put that 4 where it belongs. I put in 4 times 2. I also do 4 times 1. That's 4. 6 plus 4 is 10. 10 divided by 2 gives you, what number times 2 gives you 10?
Oh,
Put the 5 up there. So that's the method, right? Whichever method you use, you're just going to see it on paper for a free response test. We're just going to see your method. Ready for the hard one?
yeah, sure. All right.
The good thing about combustion reactions, you can easily create a combustion reaction. Just follow. There's certain numbers that you need to make sure you have.
Are you doing the lower method this time?
I'm not. I don't care what method you use. You're gonna do it.
Oh,
And tell me what your coefficients are when you come back. Right, finished?
Yeah.
What's the coefficients for the first one?
Uh,
C4H8?
We don't, it's just
Just
one.
one.
Right, so the probably you're getting ready to say is that. Depending on the type of question, you may have to say it's one, not just leave it blank, so you have to be careful of that.
You got a computer, right?
So how many hydrogen, how many waters?
H2, I put 4.
Same,
Carbon dioxide?
I put 4.
CO2, so coming out. Yeah, 2.
How many carbons are here?
4.
How many need to go here?
Wait, that's C. Oh yeah, 4. Okay, because that's octal.
You multiply that by.
Yeah.
Yep. It's only about for the element it's next to. Now go ahead and rebalance.
You know how to do the other method, not the normal method, like the normal method.
Yeah, I'm a little less experienced, but I know how to do it.
No, because I am more experienced on this, so I know how to do it.
Yeah.
I mean, I just, I'm new to the bubble method. I'm very new. This is the first time I've learned about the bubble method.
Yeah, the bubble method kind of just clicked for me. So CO. Wait, so this is oxygen and 4 carbon. Oh, yeah. So oxygen is 2,
Yeah.
4, 6, 8. So 2 for 7. Also going to be 4.
Yeah, for the bubble method, you're gonna have to use a lot of imaginary math.
Yeah,
A lot of mental math.
yeah, that's what I do. Yeah, I'm good at mental math. That's why I like it. No. What can't be good at it?
All right. How many oxygens?
4. The oxygen, so it was
So I have 8 there, 4 there.
4.
So how many do I need here?
Uh,
So 2 times what gives me 12?
6.
Does you have?
Yeah, that's exactly what I do.
Okay. So let's talk about stoichiometry. Last question for today. Given 321 grams of C4H8, how many grams CO2 is produced? Right?
How would set up the units for dissociation?
Right. So I know what? 1 mole C4H8 equals a certain number of grams. I know 1 mole CO2 equals a certain number of grams. So I could do those calculations, right? Which means I need to find molar mass of these compounds, right? Addition, 4 carbons plus 8 hydrogens and 1 carbon plus 2 oxygen, right? So I'm gonna set this, I forgot my number. I have 3, 2, 1. 321 grams of C4H8. What unit goes on the bottom?
Mole,
Nope.
no, grams,
C4H8. What goes on top?
moles.
On the bottom?
I don't actually know, 'cause I haven't gone past like just the 4 boxes.
But you just did. Follow the system. How did you get gram C4H8 on the bottom?
By going off of the.
So let's go off of that. What goes down here? Of who?
Moles of the grams.
Moles of who?
Oh, what's it called? From. C4, yeah, sorry, I thought that the 4 was even, my bad. Oh,
So at this part, you cannot go to C4H8 again. You have to go to the new thing. So the new thing is CO2. So you go to mole CO2. But the question wanted grams, right?
Yeah.
So I need one more step. What goes down here?
Moles, carbon,
CO2. And then on top will be,
moles,
nope,
grams,
grams of who?
hydrogen,
Grams of who?
carbon, CO2.
CO2. There has to be a relationship, or you cannot put one over the other. Right? There is no direct relationship between moles of carbon dioxide and grams of hydrogen, for example.
Okay.
So there has to be a relation before you can do that. This piece right here is the mole ratio from the equation. So according to the balanced equation, what's the number in front of CO2?
Let's see,
Oh, from that equation,
Yep.
it said 4.
yeah, 4.
And how many moles of C4H8?
That's just one. There was no.
Right. So that's why I use that equation, because we're gonna use that information to work this problem out. Other easy facts, right? Grams and moles is always how many moles?
So it's always one.
Grams and moles always 1 mole. And we saw over here, we have to find the mass of C4H8. And to do that, we need periodic table. All right?
I did find the mass of C for H and oh, CO2.
So CO2, 1 carbon, 2 oxygen, 12.01, 16.00. All right?
Yeah.
2 times that is 32 plus 12 is 44.01.
Yeah.
Good.
Yeah.
Plug that number in there. You do the same thing for that number. Plug it in there. Multiply straight across, then divide by what's on the bottom, and you will get your answer. Sounds like that's it. I'm listening.
I had I had questions on these ones. You didn't go through that. I did ask you earlier. There was questions, these questions on the sheet 16 to 18. If we can go through them.
So
Yeah, 4 minutes.
Those would have been wrong. Yeah.